Hey, check it out. I lied. We're going to learn some more about freezing point depression right now. All right, so as we mentioned, if you add a solute, either a polar or ionic compound to water, we're going to lower the freezing point of that solvent, of that water. So one classic example of that is the use of antifreeze. So your car contains a radiator, and the job of the radiator is to move heat away from the engine block to the outside environment and then let the blowing air over the radiator take that heat away. And the radiator is full of water, and that water is a very good absorber of heat. And one of the reasons you have one is that if the temperature of the combustion going on inside of your engine gets too high, it can actually cause the metal of the pistons to begin to melt. And once that happens, once you have a molten engine block, it's over. The engine is done, and that's a very expensive repair. So you have a radiator who moves heat away from the engine. One of the problems, though, is because it's full of water, if you were to live in a very cold location where it gets below freezing, the water inside the radiator could freeze. And since water expands as it turns to ice, that expanding water could basically rupture the radiator, causing all the fluid to leak out of it, and now you're going to be replacing a radiator, which is also an expensive proposition. So one of the answers to that story is to use antifreeze. Basically, we use a substance called ethylene glycol. It's basically related to sugars, and this ethylene glycol is really good at lowering the freezing point of water. In fact, it can lower the freezing point down to about 30 below 0 Celsius. That's pretty dang cold. That's colder than your freezer, and there are not that many places on Earth that get that cold in the winter. So unless you live in a place like Fairbanks, Alaska, this pretty much does the job of preventing your radiator from freezing. Now, ethylene glycol is a clear liquid, and so if you saw it, you wouldn't know the difference between it and water. So one of the things that they do with antifreeze is they color it this green color. That way, if any of it spills on, or you have a leak in your engine, in your radiator, and it gets on the ground, you know that you've leaked it out. Now, why do you want to know for sure that this has gotten on the floor, that you spilled it? Well, as it turns out, this solution is very sweet to the taste. So if any of it gets on the ground, your dog or your cat will come along and be like, oh, that tastes good. I'm going to lap that up. A toddler will walk over and say, oh, that tastes good. I'm going to drink some of that. But the problem is, it may taste sweet, but it's deadly. And so you don't want to kill your pet or kill your toddler by allowing this antifreeze to be laying around. And so they color it green so that if you see it, you know, oh, there's a spill here. I need to get this taken care of. Now, there are less dangerous alternatives out on the market. So there's a substance called propylene glycol, which does a similar thing that ethylene glycol does as far as lowering the freezing point of water. And it is a less toxic alternative. It's a little more expensive, and so some people don't be like, oh, we'll spend an extra few bucks, but isn't it worth it not to kill your dog? I'd say so. All right, so there are places around the world that get very cold, and that can result in ice forming in the cells of plants. If you've ever tried to grow some vegetables, maybe you're trying to grow some zucchinis or some tomatoes, and you get a hard, unexpected frost too early in the season, that plant is dead. All those leaves just wilt and wither away. And what happens is that ice crystals begin forming in the water of the cells themselves. And as these ice crystals form, they pierce through the cell membranes of those water molecules, of those plant cells, and rupture the cell membrane and spill out spill out all the contents of the cells. So many, many plants are unable to deal with any kind of freezing conditions. And yet, you know that there are plants out there who can survive extremely cold conditions. If you think about the trees growing high up in the mountains where we're going to get sub-zero temperatures, who live up in the Arctic climates, how are they able to survive that cold, icy environment where ice could form in their cells? Well, a lot of these plants have their own cellular antifreeze. Essentially what these plants do is that they concentrate salts and sugars into their cells, especially in the wintertime, to lower the freezing point of water and avoid ice formation in their cells. There are some animals, like insects, who can do the same thing. So the concept of frostbite is that ice is forming in your cells of your skin and tissues, and as those ice crystals grow, they pierce through the cell membranes and they cause the cells to die. So that's frostbite, and frostbite can often be a permanent destruction of those tissues. But there are insects who live up in the Arctic where temperatures routinely drop to 30, 40 below zero, and they're able to survive it by having antifreeze in their cells that help them avoid freezing by lowering the freezing point of water. A lot of times you can tell where this critical temperature of ice formation occurs by looking for the tree line. So this is a picture in Colorado at the tree line. Below that tree line, a forest of spruces and firs is able to grow just fine. Above that tree line, it becomes virtually impossible for those trees to survive. Now, as it turns out, almost all plants have a minimum survivable temperature of about -40 degrees Celsius. They can basically lower the freezing point of water down to about that point. So if the temperatures remain above 40 below Celsius, they're able to avoid ice forming in their cells. If temperatures drop below that, ice will form in their cells and they'll suffer ice damage. So this tree line in Colorado occurs at about 12,000 feet. 12,000 feet is the line where below that line it never gets to 40 below 0 Celsius, but above that line it does. And oftentimes in many of these places it is a very distinct line of trees below and no trees above. In New Hampshire, the tree line sits at about 4,500 to 5,000 feet. It's colder in that region relative to Colorado, and so the tree line occurs lower. Here, very close to the tree line, you'll notice that this tree is suffering ice damage. So you'll see on here that this tree is having damage to its leaf tissues. A lot of these branches are either devoid of leaves or damaged in some way. And so this tree is basically suffering the effects of being near that 40 below 0 line. And it's eking out a living, but suffering damage because of it. A little bit higher up, you'll be above the tree line and there won't be any trees any longer. Okay, one more thing before we move on to boiling point elevation. Check out the video I posted about how to make ice cream, because making ice cream is all about the concept of freezing point depression.